Hey everyone, in this video we are going to solve binary tree level order traversal question on Leetcode. So we are given a root of a binary tree and we need to return the level order traversal of its node, which means we have to print the node level by level. So on first level it's 3, so just 3 in a single array. Then on second level there are 9 and 20, so 9 and 20 in another array. And then on third level we have 15 and 7, so 15 and 7 in third array. So we'll be returning the output in this form. So let's see how we can do it. Okay, so to solve this particular question, we're gonna need three things. First, a queue, because we are gonna need the FIFO property, that is first in first out, in order to solve this particular question. And initially, we'll put the root inside a queue. Next, we'll need a final array, our result array, which we'll be returning, and it will contain all the level order traversal of this particular tree. And third, it will be a temporary array. So let's call it let temp equals to. Okay. So right now the size of our queue or the length of our queue is 1. So what we are going to do is loop through our queue, remove the element from our queue one by one until our size becomes 0. And once it becomes 0, we're going to push that many elements inside this temp array. So what we need is a for loop. So for let I equals to 0 to I is less than size and I plus plus. So this will be our for loop. And inside this for loop, what we'll be doing, we'll be removing the first element from the queue, that is using the FIFO property. So to get that, we'll use the shift method in JavaScript. So what we'll say, let's say current. We'll name the variable current, and inside this current variable, we'll use queue dot shift. What shift will does, it will remove the element from the it will remove the first element from our queue and it will return it to us. Next, what we're going to do, we need to check if this particular current node that initially, which will be the root node, contains a left child and a right child. So if it contains a left child, add it to the queue. If it contains a right child, add it to the queue as well. So what I mean is, if current dot left exists, push it to the queue. Queue dot push current dot left. Similarly, we'll check if current dot right exists. If current dot right exists, we'll push it to the queue as well. So queue dot push current dot right. Okay. Now, after we have checked if the left child exists or not, if the right child exists or not, and adding it to the queue, we'll add this current element to this temporary array that we created before. So what we'll do, we'll just temp dot push current dot val, and we'll close the for loop. So let's see how it will work. So initially, what we have 3 in our queue. So we'll run the loop from I equal to 0 to I is less than 1. So we'll get the first element from our queue, that will be 3. So current will be 3. So does current dot left exist? Yes, 9 here exists. So we'll add this left child to our queue. So 9 will be added here. Next we'll check if current dot right exists. Yes, it exists, 20. So it will be added here as well. And inside this temp array, we'll add 3. We'll have all this logic in a while loop as well. So again, the temp variable will become empty. So temp will become empty again. And this time our size, instead of 1 it will be 2, because we have removed 3 from here and 9 and 20 are still left here. So the loop will run from I equal to 0 to I is less than 2, that is 2 times. So we'll first pop or get the first element from our queue. So it will be 9. So does 9 have a left child or a right child? No, it does not. So we'll not do anything and simply add 9 to a temporary array here. Now our loop is still not terminated yet. I will become 1. I is still less than 2. So we'll remove the next element from our queue, which is 20. We'll check if the left or right child exists for 20. Yes, it does. So for left, we'll add 15 here. And for right, we'll add 7 here. And then at last, we'll push the current.val, that is 20, to our temporary array. So temp will become 9, 20. And each time this loop will run, this whole logic is completed, his for loop is completed, will store whatever value is inside the temp in a result array. So initially it was just 3. Now it will be 9, 20. And next, this whole code will run again. So temp will again become an empty array. So temp will again become an empty array. Now we'll run the whole logic again. So what will happen? This time the size of the queue is still 2. Why? Because we popped or removed 9 and 20 and added 15 and 7 in the previous iteration. So this time loop will run from I equal to 0 to I is less than 2, that is 2 times. So first we'll remove the first element from our queue, that is 15. We'll check if 15 does have a left child or a right child. No, it does not. It is a leaf node. Then we'll simply push it to the temporary array, our temp array. So 15 will be added here. Next, I will be 1. I still less than 2. We'll get the next element from our queue, which will be 7. Now we'll check if the left or right child exists for it. No, it does not. So we'll simply add it to our temporary array. So 15, 7. Then I will become 2 and the loop will break. And then again, we'll push this temporary array to the result array. So 15, 7. So this will be our final array, which will return. So the time complexity for this solution will be O of n, where n is the number of nodes in the binary tree. Space complexity, it will also be O of n. Why? Because we are storing all the nodes in our result array and then we are returning it. Okay, so let's see how we can do it in code. Okay, so first let's create a result array. So result equal to an empty array. Then we'll just check if root exists or not. So if root does not exist, we'll just return this empty array. Next, let's declare our queue data structure. And initially we'll push the root to our queue. Then we'll run a while loop, while queue dot length exists. So until there is some value present in this queue, this loop will run. Next, we'll write the whole logic that we discussed. So first we'll create a temporary array, temp equals to an empty array, and we'll calculate the size. So currently the size will be queue dot length. Next we'll run a for loop. So for let I equals to 0, I is less than size, and I plus plus. And inside this for loop, what we'll do? First we'll get the element from our queue, the first element, using the FIFO property or using the shift method. So it will return as the first element in our queue. Next we'll check if for this current node left or right child exists or not. So if the left child exists, we'll add it to the queue as well. So queue dot push current dot left. Similarly, if current.write child exists, we'll add it to the queue as well. So queue.push current.write. Next, after checking these two conditions, we'll just push the current dot value in our temporary array, in our temp array. So current dot val. Now after this for loop, we'll push whatever value was stored in this temp array. So result dot push temp. Out of this while loop, we'll just return the result array. So let's just run it. It's working. Let's submit it. Okay, cool. So this was it for this video. Thank you for watching.